Hello folks, welcome back for a bit more integration. Now I've had a request or two for biscuit reviews to go on, so I've had a little look in the cupboard downstairs, and I found this rather unfortunate looking character who's in two parts there. Now I don't know if you can quite see that. It's what's known as a malted milk. Someone once, when I was doing a pie chart, said that the malted milk was their favourite biscuit. To be honest, I can't see it myself, but we'll be testing that in a minute. Beforehand, have a little look at this little image that's about to come up, because what we're going to be doing today is all about finding the area under a curve, and integration allows us to find all the area to the left of a stated value of x under a curve. I'm going to give you a little time to copy this down just whilst I tuck into the malted milk and tell you what I think of it, which just tells you about it. So the integration for any curve with the equation y equals a function of x allows us to define the area under the curve to the left of a substituted value. So you'd integrate, if you wanted to know, to the value all to the left, and that was 3, say, then you would put 3 into your integrated function, substitute that in, and that would give you the area. You'll see about that later. So here's the only example I'm going to show you today, finding the area of the finite region between the curve with equation y equals 20 minus x squared and the x-axis. Whilst you're writing that down, I'll just confirm that the malted milk is certainly a waste of sugar and milk and whatever else they put into the disappointing item. Right, so what does this look like first of all? So what I would encourage you to do is make a sketch. And to do the sketch, just get your calculator out, whack it in on the graphing function, press draw, and you can see what it is. Now I could mess around with the axes and get it there, but it's a fairly basic one there. If you look at it, you think, oh yes, it's a negative quadratic, so that's what it's going to do. It's going to basically make your sad face upside down smile. So just to imagine what's going on, if we make a little sketch of that now, we have got something doing something like that, and what we're trying to do, finding the curve between it and the x-axis. So we're looking at the positive area, we're looking at all the area that is above here. Now before we can do this, we need to know what that value is there and that value is there. Now you could do that by factorizing this, or as you've got this up already, it's not going to cost you any marks at all, you can just press Gsolve and then root, and that gives us -5 on the left hand side and 4 on the other. So I'll just label my sketch. Right, now the next thing I need to do is I need to integrate between x is 4 and x is -5, 20 minus x squared dx. So that means with differentiating with reference to x, doesn't it? So then we're going to integrate this. So how do I integrate that? And so right, this is going to give me 20x, add 1 to the power here, gets me x squared, divide by the new, so over 2, and that's a negative, and same again here, go up to x cubed, divide by the new power, x over 3, and then I will have between the values of 4 and -5. Then we're going to be doing what we were doing last time, which is putting the values of 4 into here and -5 into there, and then taking this bit away from that bit. So 20 times 4 is 80, minus 4 squared over 2 minus 4 cubed over 3 all take away negative 100, because 20 times 5 is 100, and then you have to be a little bit careful here because we're taking away negative 5 squared over 2, which will give us a positive, but then not so on the next one. So be very careful about how you put that in the calculator, or you can work it out, and that should give you all 243 over 2, or 121.5, isn't it? Yeah. And you don't normally have to give the units, but it would be units squared as well, wouldn't it? Okay, and that is the only example for today. In terms of practice, not necessarily important to do all of the exercise. If you look at the exercise 13, you do all of question 1, which has got 4 different ones on it, and then 7, 8 and 9. If you can do those without any real difficulties, then that should be enough. If you do find that you got to the end of that and you've had difficulty, you need to come back and ask for some help and everything, then I would say go back and have a go at questions 2, 3, 4, 5, as many as you need until you feel comfortable doing this. Okay, see you tomorrow. Goodbye, folks.